Welcome back to my channel. In today's video, I'll be discussing about another function which is y equals to 1 by x power 2n. So, this is a generalization of the graph of the form 1 by x square power n. That is the different powers of 1 by x square. So, let us understand how this works. So, here we have this graph which is y equals to 1 by x power 2n. So here n belongs to the set of integers which is the z. So for different values of n like 1, 2, 3 and so on, we will get different graphs like 1 by x square, 1 by x power 4 and 1 by x power 6 and so on. Here I need to mention that n belongs to the positive integers, not the negative ones. For negative ones, we will get, so suppose we have a negative integer like this. So in that case, x will be 1 by x power minus 2. This will give x square. So those kind of graphs, I have already mentioned them previously. So please check out my videos on the graph x square, x cube and x power 2n and x power 2n minus 1, those kind of graphs. So first, here we have what is that all the properties are same as the graph of y equals to 1 by x. So it should not be x, it should be x square. So the properties of the graph y equals to 1 by x power 2n is same as this graph y equals to 1 by x square. So check out the video on y equals to 1 by x square. Okay, next is here we have for n equals to 1, we get y equals to 1 by x square. Next 2, y equals to x power 4. For 3, y equals to x power 6. So the powers are rising and these are all even powers. Now again, we can divide the real line into 4 parts. In those 4 parts, these graphs behave like, in some places this is higher and in some places this will be higher. So we need to check that. So let me draw the real line, which is this one. We can divide it into 4 parts like this one. So one part is minus infinity to minus 1. Next part is minus 1 to 0. Next part is 0 to 1. And the last part is 1 to infinity, this part. Okay. Next, for x greater than 1, we have this inequality. So let us check with an example. So for x greater than 1, we can take, suppose, let me write it down. So suppose we take x equals to 2. So here we have all the reciprocals. So for reciprocals, we can write 1 by 2 square, 1 by 2 power 4, 1 by 2 power 6 and so on. So what will happen here? Here 1 by 2 square, which is 1 by 4, is obviously greater than 1 by 2 power 4, which is 16, 1 by 16. So this inequality must hold. So here we are getting this inequality. This is correct. For the next range, which is 0 to 1, we have this inequality here. So 0 to 1 means this portion. The previous portion was this portion. Now we have moved to this portion. So here, if we take another example like this, so between 0 to 1, we can take an example as x equals to 1 by 2. Now here we have all the reciprocals. So the reciprocal will give this 2 square, 2 power 4, 2 power 6 and so on. So here we can see that this inequality holds. This is 4, this is 16, okay, and so on. So in this region, this inequality holds and it is true. Now move on to the next region, which is this one, minus 1 to 0. So that means this part minus 1 to 0. What happens here? Here this inequality holds. So let us now take an example. So an example would be x equals to minus half. So if we take the reciprocal, it will give 2. But as the powers are even, so there will be no minus term. So we can write it as 2 square, 2 power 4, 2 power 6 and so on. And here we can see that this inequality holds. So here this one is true. Now moving on to x less than minus 1, we have come to this region, which is this part. So in this part, this inequality holds. So if we take another example, so that would give, suppose let us take x equals to minus 2. So by taking the reciprocal, what we will get? We will get 1 by 2. Now as here is minus, but the powers are even, that is 2, 4, 6. So the minus term will not be there and we will get only 1 by 2 square, 1 by 2 power 4, 1 by 2 power 6 and so on. And here as all these are positive, so obviously 1 by 4 is greater than 1 by 16. So this should be the direction of the inequality. So here for x less than minus 1, this one is true. Okay, now moving on to the graphs, we have already plotted the graph of the function y equals to 1 by x square. So that is the graph of the function, this black color. So let me denote the black color here is the 1 by x square. Next is the blue color. Blue one is the 1 by x power 4. Next is the purple one, which is 1 by x power 6. And lastly, the red one, which is 1 by x power 8. So again, if we try to check with respect to those different 4 intervals, we can see that here the graph of 1 by x square is at the top and the red one, which is this one, is at the bottom. So here what happens? 1 by x square is the highest. So this one is true. Next, let us see this interval, which is 0 to 1 interval. Here 1 by x square should be at the bottom and the graph with the highest power, that means 1 by x highest power, that must be at the top. So obviously in this part 1 by x square is at the bottom and 1 by x power 8, which is this red curve, at the top. Similar thing holds in the interval minus 1 to 0. So for minus 1 to 0, we can see that the black curve is at the bottom and red curve is at the top, and this one holds here too. 1 by x square is lesser than other ones. And for the last part, which is this one, we have 1 by x square is the highest. So the black curve must be at the top. So here we can see that black curves at the top. So these curves are represented by this graph. So I am sure now that we can plot any kind of these graphs 1 by x power 2n minus 1 now. So okay, so from the next video I will start on the rational functions like x power 1 by 2, x power 1 by 3 and their generalization. Thank you for watching this video. Please like and comment on this video and subscribe to my YouTube channel.